Hi everybody, I wanted to have a look at the written homework for week 2. So on number 1, I don't have too much to say. It's, whenever you're doing a row reduction operation, it's very, very easy to make little arithmetic mistakes. So just try to be on your guard for little arithmetic mistakes. I try not to, I'm not super harsh about grading penalties for little arithmetic mistakes, unless it really changes, how the problem works out, which is a thing that can happen in linear algebra. So be as careful as you can with your arithmetic. I try to be understanding because I make plenty of arithmetic mistakes myself. Okay, so reducing to row echelon form, right? First we need to use this 2 to get to eliminate the -2 below it, which I've done here. And then we just need to make these leading entries in each row be 1. So not every textbook defines row echelon form or requires leading ones from row echelon form. And honestly, it's not super important whether there are leading ones or not, but just for consistency, for this quarter in this class, we're going to require leading ones for our row echelon form. Now for reduced row echelon form, you do have to have the ones. All sources agree on that. And part of the reason is because we really want reduced row echelon form to be unique. That's part of what makes it important. And if you don't require your leading entries to be 1s, then this form isn't unique. So it is in reduced row echelon form, it is important to have leading 1s here. In number 2, I don't think anybody really made any mistakes in number 2, so nothing to say there. So in number 3, we see the biggest mistake that I saw while I was grading this homework. So this is an augmented matrix, right? So this is representing a non-homogeneous system. It's an augmented matrix. And that means that the last column is not corresponding to a variable. So the first column corresponds to a variable x, the second column corresponds to a variable y, and the third column, that's the augmented column. That doesn't correspond to a variable. If we wrote out this system, it would look like x equals 3, that would be the first equation, y equals 14, that's the second equation, and then this third line gives us the equation 0 equals 0, which counts as an equation, but doesn't really add anything to the system. Now something you may notice about this is there is no z, right? There's no z in this equation, so the most common mistake was that some people said, well, z is a free parameter. And that's not true because z isn't in this system at all. Right? If z were part of this system, we would have another column in here, but we don't have another column. So z is not a variable in this system. All right, for number 4, for this matrix, if it's augmented, then parameterizing the solution set looks like this, and then if you want, you can write it vector style like this. I don't think there was really any problems that we ran into with that. And then assuming that this matrix is non-augmented, the difference is if this is non-augmented, so this column is for x, this column is for y, this column is for z. If this matrix is non-augmented, representing a homogeneous system, then this last column is also representing a variable, and so we end up with another variable like this. On number 5, finding the rank of this matrix, I think the only mistakes I saw was if you make any kind of arithmetic mistake, then you'll accidentally make this matrix rank 4. That's just sort of a property of matrices. If you just randomly choose numbers for a matrix, it will have as large a rank as it's possible to have most of the time. So if you have a matrix that doesn't have full rank, so this one could have rank 4, except it actually has rank 3, if you make any sort of arithmetic mistake as you're doing this reduction, you'll accidentally change the rank to 4. So be super careful when you're doing your row reduction. In number 6, so there are 2 free parameters here. I think the only mistake I saw people make was misidentifying how many variables there are. So this is a homogeneous system, so how many variables are there? Well, this is an unaugmented matrix representing a homogeneous system, so there's one variable per column. And there are 5 columns here. So a few people accidentally said that there were 4 columns, so just be careful there. So 5 variables, 4 columns have pivots because it's rank 3, because the matrix is rank 3. That means there are 2 columns without pivots, and so there are 2 free parameters, since every column without a pivot corresponds to a free parameter.